system. Let's read what it says here. Widely accepted that an aircraft's fuel system has more profound effect on its performance than any other system. This one has 11 separate tanks, 21 pumps, 43 valves, one of the most advanced in the world. The size and scale of the A30. Here we go. Owing to the fact that it's fully loaded, there is some 118 tons of fuel being carried in each wing. And are you reading that? Am I in the twilight zone? Here we go. Yeah, and the air can carry 320 litres of fuel, or about 250 metric tons.
250 metric tons.
250 metric tons.
250 metric tons.
With a jaw-dropping 450 tons of weight. The engines swallow more than 13,000 litres of fuel every hour. To feed the beasts, 12...
Now, that's just... They're not even showing you the air compressor behind here. But that's all it is. It's an air compressor. Hold on, we'll go on. We'll continue with this.
12 enormous fuel tanks live inside the 30-metre wings. The fuel tanks hold 189,000 litres.
189,000 litres. Let's just double check. I always do. Hold on.
The fuel tanks hold 189,000 litres.
Wow. 189,000 litres. So I've just tapped that in there. So that's just... Anyway. A 25-metre swimming pool. That's your average local swimming baths for us poor bastards that go to the public baths. Well, they hold 375,000, right? So half a swimming pool. Can I get an image? Let me get an image of what I'm trying to say here. A swimming pool. They've averaged it at about like that, yeah. 1.5 meters deep on average of fuel, flammable fuel. There's a girl lining the tanks with Kevlar liners, so the wings. So she must be the size of a rabbit. I'll explain why. 95,000 kilograms of fuel in all of these tanks. Right, I did my usual production skills here. Right, I did save some. Right, so here we have a nice view with some people on the ground, but look at the skinny, tiny little wings. They are tiny. You know, probably the thickness, not even the thickness of this book, maybe. Okay. Right, so then we'll go on here. They're showing you there's various places where all the tanks are supposed to go in, but there's all these struts supporting the wing to give it strength, because obviously when you're flying supersonic, these wings are going to be subject to some immense strength, you know, forces and whatnot. But then also you've got to put room for the actual beautiful engines themselves underneath here. And anyway, I've done that page, sorry. And there's what did it say here? Smoky Joe's. Well, nitrogen oxide, nitrogen. If you're separating the air, which I'm telling you these engines do, nitrogen oxide will cause this smoking effect. I do believe I read about that. Here's the showing you the tiny thin. Look how thin those wings are, yeah. And there's the engine. You can crawl inside that bit, but that bit you're not going to crawl inside there. And what I'm saying to you, that picture was faked. More pictures. I mean, it's a marvel of engineering, an absolute marvel. Excuse me. And I can get there you are. Absolute. There's these are steps designed for a human to walk up, not a giant. And the steps have you can look them up. They're a certain size so you don't trip. And then look at the tiny little wings. There's no liquid fuel gone into any of this, is what I'm getting at. A large mass of air must be supplied to the turbine in order to produce the necessary power. The mass of air is supplied by the compressor, which draws the air into the engine and squeezes it to provide high pressure air to the turbine. Now, I'm just going to read this next bit, because this is the crux of it to me. Right, if the compressor and turbine were 100% efficient, the compressor would supply the air needed by the turbine. At the same time, the turbine would supply the necessary power to drive the compressor. In this case, a perpetual motion would exist. That's where it should end, because they have invented a perpetual motion free energy generator.
Remote control, electric motors, robotics, lasers, 120 years, 30, 40 years ago, folks. And look at this, limitless free energy. So what do you think the powers that be, the power and control, have had? They've had Nikola Tesla technology of free energy for over 120, 30 years. For those that think that we need fuel to run planes and stuff, that's ridiculous. It's absurd, but that's all they offer us, folks. So yes, it is valid to question the stuff, whether jet fuel is in planes or not and whatnot. So I want to just bring this to your attention and also introduce those that you don't know to Victor Schauberger, another one that gave us free energy. Here, take a look. The majority believes that everything hard to comprehend must be very profound. This is incorrect. What is hard to understand is what is immature, unclear, and often false. The highest wisdom is simple and passes through the brain directly into the heart. Victor Schauberger. He developed an aircraft engine that would work on the same principle as the Trout turbine by using air as the fuel source. It would suck in the air and convert it to fuel while flying, and at the same time create a vacuum from in front of itself, which would move continuously without resistance. Perpetual energy. The vortex, right? Free energy. Now think about the Big Bang Theory. When do you know when explosions create things? No, explosions break things apart. What he put together was implosion to create energy like a tornado concentrating its energy.
Right, this is evidence on why jet engines do not hold any liquid fuel in the wings. If you notice here, okay, all of these access panels are open. These are a good idea for when things go wrong in the future. You can just remove them and get your hand in there and fish through wires and whatnot. But they do this stress test. Okay, I'll play a bit more.
We have in front of us more than 2,500 tons of steel.
No, you don't. It would never fly. It's made of aluminium and titanium. It's the most strongest the titanium strongest lightest weight material on Earth. How it's made is debatable, but you thin it out and it's extremely strong and lightweight. Why most of the aircraft's built of it. It's not a big lump of steel that they try and get off the go. What a lead! See, they're just lies.
This is the cage of the bird. We will go to the extremes to check.
Right, extremes to check the structure of the bird, the aeroplane. But at no point here do you see any liquid fuel sloshing about, being injected. There's another stress test as well, which I can't find. I had it on my old channel where you can look straight down the wing. They do not put any liquid inside this jet fuel or water or anything else to test the wing. And if you're doing a stress test, you would need it fully weighted out if there was any liquid inside this to give the full real life scenario, but they don't.
We have more than 5.2 meters displacement.
Look, not only are my videos aimed at trying to free us from the tyranny of these people that are charging us for jet fuel and electricity, etc. I'm also doing these for people that have problems flying in aircraft, because there is nothing to be afraid of. They're designed to crash land. They're an absolute engineering marvel, and I will keep harping on about this. Nothing to be embarrassed about, far from it. It's just we shouldn't be paying for the fuel that doesn't exist. Well, it does. It's the air, and you breathe in it, and your body utilises it, and that's just how it is. But this is evidence number 3. They do the stress test with not a single bit of liquid inside it. And need I say any more? But I will find you some more evidence. There's plenty of it. This is supposed to be a fuel tank, aviation fuel repair. Let's expand that, and I want you to pay attention to the bottom pieces here. But anyway, let's just play.
Now we're in the same thing. I'm gonna show you how to climb in. There's only one way and one way out.
If you think this is a fuel tank, you're a complete and utter moron. Anyway, I shall carry playing this. There is nothing in this. If this was a fuel tank, this would be sloshing fluid backwards and forwards through these holes, okay? And you would feel it. The plane wouldn't be able to fly. Anyway, he's going to look back, and he's looking at this, the giant holes here. I don't know whether these are electrical connections. They look like electrical cables, which you wouldn't be running them through any form of liquid. Just common sense would tell you that. These are not fuel tanks. Hold on, I'll play a bit more. This whole thing, if this was a fuel tank, the plane wouldn't take off if this was full of liquid fuel for a start. It wouldn't be able to handle it. It wouldn't be able to do the turns with all that fuel slushing about. You know, it's a nonsense. Look how big the fuel tanks are. That's where all that liquid fuel's going, and then equally, not a drop or a dribble of fluid inside these things. You know, it's just, I can't emphasize how stupid this is. Again, electrical connections and things are. Do I need to show you any more? Are you convinced that this isn't a fuel tank with all these holes everywhere? And you know, you just picture that plane taking off now with this full of liquid sloshing about, and it's not hermetically sealed. It's, you know, there's some electrical connections. You know, what more can you say? What more needs to be said if you can't work out that planes run with compressing the air, and which is electricity and stuff. Right, this one is on flaps. This is the underneath of one of the wings. Just look at the amount of hydraulics going on here, and what we're trying to look for is fuel tanks. Can you see any? There isn't any. Here we go. It goes underneath here, and look at this. Look at the thickness as well. Yeah. It is an engineering marvel. I'll turn the sound up if you want. It's quite annoying. Look, they are. All this is going on. All the electronics hydraulics. There's more piping as well going from the to the actual gas turbine engines. There's more of the piping inside here. I mean, look at this. Look at it. Look at the actual size of it as well here, yeah? No room at the inn for those tons and tons of liquid fuel they keep telling us about. It's only a quick video, but I think it pictures speak 1,000 words. You don't need to be an engineer to realise the amount of stuff that's required. Yeah, this is heavy gear. This is proper stuff. Anyway, I'm gonna give full credit to this YouTuber here, Jagira 45, Boeing 737 flaps extension and retraction. Thank you very much for this, because to me it's absolutely fabulous. Look at that. Yeah, there are no fuel tanks. Come on, can you not? I mean, wow.
So far. Holy shit.
A section called electricity in the atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. According to Feynman, this extends upward to 50 kilometers, or 31 miles, where the air is very conductive. This is the case in fair weather. In stormy weather, like a thunderstorm, things are quite different, and I won't talk about that here.
Let's take a look at these. They're a bit loose. This is normal. This is the way they should be. Here we are outside with our cutaway. This is the exact same thing we were just looking at. This is an LM1500 J79 rotor. And what's different about these blades?
Jet engines use air as their fuel. Evidence. Tiny little wings. Tiny wings. This is the missiles. Then you have to have room for these to go inside. They fold up in there. This is the engine part that goes all the way to the back. And this is where your guy sits in it, yeah? There's no room for fuel tanks. Right. Another one. Skinny, tiny little wings. Air goes in, air is compressed down. It is ignited because air is a gas. You can ignite it when it's hot enough. It's combined and then it comes out the back and gives you propulsion. And inside here is showing you what are these missiles and stuff, and obviously you've got to have room for the landing gear in there somewhere as well. Right, again, skinny tiny little wings, and a lot of these wings on these planes fold up. There's a folding bit here where they lift up so they can go down into the aircraft carriers. Air intake, all the combustion and everything happens in both sides of these. No room for fuel tanks. No room for fuel tanks. That's just gas. The air that's been compressed gets really, really hot and is ignited. It comes out the back. The flames you see are no different to a flame you'd see on a gas hob. Beautiful. And here it is. This is an engine. But they never have any fuel dripping on the ground. They don't put down anything because there is no liquid fuel going into this engineering masterpiece. And here we have a Fibonacci spiral because it uses Fibonacci compression. And yes, it needs electrics. Yes, it needs oil inside this to keep the bearings lubricated like a fidget spinner. And there is no liquid fuel. This is how this thing sucks the air in, superheats it up to such a high temperature that it can be burnt, and out the other end comes the hot air going at such a velocity that it causes the thrust to push the thing forward. And there's your Fibonacci spiral. Anyway, of course the military are going to keep that secret, that knowledge, because, you know, they want to charge us for it. They want to tax the air we breathe. And the same engines are used in the production of electricity, and we're paying for air in that industry as well. You know, it's something to be proud of, and as a human race, what we've achieved here. But no, it's hidden from us all. And I mean, just it's yeah. The Ever can carry 320 litres of fuel, or about 250 metric tons. Now, a ton, what's a car, 2 tons? On the wings, inside the wings, providing 8,000 miles of a journey. Oh, there you go, there you go. So that's showing you these fuel tanks. So basically, when you watch an aircraft come into land, when they're coming in with turbulence and whatever else, yeah, near enough, one of these struts can take the whole weight of the aircraft, because as it comes in, sometimes they come in at an angle and they bounce down on one of these sides, sometimes even just one of these tires. But what we're looking at here is a pathetically lightweight tire. Yes, it's big, but it doesn't weigh a lot. I mean, they're making out, look, I mean, it just rolls, piece of piss, absolute piece of piss. And no doubt he had to study for two years to get a degree in how to change a tire. That's the way the world's gone nowadays. I'm not having a go at the guys doing the work. It's not what it's about. It's the whole bullshit lie of liquid fuel that it's all about. But I can't remember whether it was Goodyear, don't quote me on, or Michelin, one of these two. There was a plant over here that used to make the tyres for the aircraft, and I can't remember off the top of my head whether it was 40 psi, something like that. But it's not a massive amount of psi. And just look at these things. That's supposed to be a 6-ton engine there, adding on all the weight of this aircraft, all the weight of the passengers. It's just nonsense. It's just a joke, like everything else in this industry. It's just, the figures are just ridiculous. They just make them up. There's that back one with the starter car, and then there's all the pipes that have to go to feed all of these beautiful engines.
Now, you've seen this thing many times, but we're going to take a much closer look at it today. What this is an air turbine starter for a jet engine. This jet engine. And there we go, our starter's attached, the air line is hooked up, the start cart's in position, and Mr. Bill is warming up the fuel system so we get a little bit of light rain just before we run this engine.
This one is just on the complete comedy that is going on here. Anyway, let's just play it.
We have water ingestion testing. We take in about 4.5 tons of water a minute and show that.
What was that?
Tons of water a minute. We take in about 4.5 tons of water a minute.
Yes. So when you're talking about combustion in the traditional sense that we interpret it, with a flame and one thing and another, that wouldn't be advisable if your car engine was being constantly sucking in that kind of volume of water, would it? Anyway, I'll play on.
and show that the engine can continue to operate and not stall, taking in that kind of volume of water. We also do hail ingestion testing. We have several little cannons that shoot hail into the engine. They shoot about 3/4 of a ton of hail in 30 seconds.
Anyway, I'm going to leave it there. I mean, what an amazing machine it is, the jet engine. I'm just, you know, I'm going to leave you with that. And I no doubt she's an expert in how they work, because everybody seems to be, don't they? But yeah, as I said, they can work with water, liquid, obviously, because they don't work like you think they work. But anyway, I'll leave it there.